OH groups of alcohols can be converted to a tosylate. So here we have the OH group getting converted to the tosylate in order to create a good leaving group to be able to do a conversion to an alkyl halide. And forming the tosylate is particularly advantageous when you have a secondary carbon with a chiral center. For both primary and tertiary alcohols, we looked at using HCl or HBr for this reaction, which is advantageous over this two-step process. The reason why we're using the tosylate instead of HCl or HBr for a secondary alcohol where there's a chiral center involved is because we want to avoid inversion, we want to avoid racemization of the chiral center. And so in this case, we're able to get complete inversion of the chiral center and no racemization. So it's a two-step process where you first utilize tosyl chloride and pyridine to form the tosylate, and then you can use a good nucleophile, such as chloride or bromide, to do the SN2 reaction. And so this is how you might see it, the reagents written over the arrow, right, to convert a secondary alcohol, chiral alcohol, to an alkyl halide, utilizing an SN2 reaction and inversion of the chiral center. So let's look at the mechanism involved. So the first step, we have the conversion of the alcohol to the tosylate, and that uses tosyl chloride or TSCl and pyridine, and that's commonly abbreviated OTS. So let's look at the mechanism of how that is transpiring. So we have the alcohol and then tosyl chloride, which is actually a very large group, also known as para-toluene sulfonyl chloride. Drawing the lone pairs, since we're showing the mechanism. So again, the alcohol group, in particular the oxygen, is nucleophilic. So it can do a nucleophilic attack on the sulfur. And since sulfur is a large atom, we can kick out chloride. So the intermediate has a positively charged oxygen atom. And we've kicked out some chloride. Again, pyridine is used in this reaction, and that's because pyridine is a non-nucleophilic strong base, and it will prevent the formation of HCl if chloride had to act as the base. So we can deprotonate using pyridine. And then this produces the product, which we call a tosylate or tosylated alcohol. And byproducts of pyridinium chloride. Drawn out, this would look like and the reason, again, that we would go through the trouble of adding this tosylate group is because now we've introduced a good leaving group. Whereas the OH group is not considered a good leaving group for substitution reactions, the tosylate is a much better leaving group. So once we have the tosylate in place, now we're able to treat this with a strong nucleophile, such as sodium bromide, and it will undergo SN2 exclusively, and the carbon will undergo inversion of configuration. So this mechanism is a straightforward SN2 reaction, where bromide does backside attack and loss of the tosylate group produces the product, which is our alkyl halide, and then the byproduct is OTS minus, and then drawn out, that would look like this. And again, this is a good leaving group because the oxygen with the negative charge is highly resonance stabilized and